Hello and welcome everybody to another episode of Paper Talks. Today we're tearing into a piece of work that isn't just making headlines, but genuinely reshaping how the biggest minds in tech are thinking about our future. It's Leopold Aschenbrenner's Situational Awareness, The Decade Ahead. If you're looking for a shortcut to understanding one of the most urgent and startling analyses of where AI is headed and what it means for everything from global power to your own job, well, you're in the right place. Okay, let's unpack this.
Yeah, this paper, it's not just another academic exercise. It's landed like a thunderclap, really. It presents this remarkably bold, urgent thesis, a real wake-up call. It's a comprehensive, almost unnerving look at the rapid trajectory of artificial intelligence. Aschenbrenner argues we're on an unavoidable path to artificial general intelligence, AGI, and then superintelligence, all within this decade.
Within this decade, that's
Extremely soon. And the paper's lasting impact is really its insistence that we move beyond, just casual speculation. It forces us to confront the when of superintelligence, not just the if. It's a call for an industrial-scale national effort, something like the Manhattan Project, to manage its development, its security, and crucially, its alignment. This isn't just another tech boom he's talking about. It's presented as a fundamental world-altering shift with profound implications for national security, economic power, even the future of democratic governance.
Okay, so it's not just a prediction. It's framed as a blueprint for immediate, serious action. The paper's core mission, then, is really to arm us, you listening, with situational awareness about what's supposedly coming and why it demands such intense attention.
Exactly. It challenges the widespread complacency you see in both the public and private sectors, arguing that the stakes are just too high for anything less than a national mobilization.
That's quite the opening statement. Let's dive into how Aschenbrenner actually arrives at such a stark conclusion. Let's start with the incredible leaps in AI capabilities that have brought us here. The paper highlights the astonishing journey from GPT-2 to GPT-4. This is where it starts to get really interesting.
Right. Just think back 4 years ago, 2019, GPT-2 was, as the paper puts it, like a preschooler. It could barely string together semi-plausible sentences, struggle to count to 5, and remember that cherry-picked example of it writing about unicorns in the Andes? That was considered incredibly impressive back then.
Yeah, I remember that. Seems almost quaint now.
Totally. Fast forward to 2023, and GPT-4 is like a smart high schooler. We're talking about a system that can write sophisticated code, iteratively debug it, intelligently discuss complex subjects. It aces high school competition math, performs at the 90th percentile on the uniform bar exam, 88th on the LSAT, 97th on the SAT. It's tackling benchmarks like MMLU and math that were once thought, basically insurmountable.
It is remarkable how quickly we adjust, isn't it? What felt like science fiction yesterday is just today's standard tool. But what's actually driving this relentless, almost unbelievable progress?
Okay, the paper breaks it down into 3 key drivers, and it consistently measures them in orders of magnitude, or ohms. Just think of an ohm as a 10x improvement. So a 0.5 ohm per year means capabilities roughly tripling annually.
Right, okay. 3 drivers. What's the first one?
First, massive compute scaling. From GPT-2 to GPT-4, the raw compute used increased by something like 3,000x to 10,000x. This isn't just Moore's law. This is mammoth investment driving roughly half an ohm per year. Projections suggest another 2 to 3 ohms of compute by 2027. We're talking about training clusters costing $100 billion or more.
$100 billion?
Yeah.
For one compute cluster.
Yes, and powered by massive new energy infrastructure.
It's like building a small city just for AI training. The energy demand must be astronomical.
It really is. It could consume potentially over 20% of current U.S. electricity production. The sheer scale is difficult to grasp.
Okay, so massive compute. What's the second driver?
Second, we have algorithmic efficiencies. This one's equally important, maybe even more so sometimes, but often underrated. It's also progressing at about half an OM per year. For example, the cost to get 50% accuracy on that math benchmark dropped by nearly 1,000 times in just 2 years.
1,000 times cheaper in 2 years. Wow.
Yeah. And we've seen models like GPT-4o and Gemini 1.5 flash dramatically cut inference costs compared to the earlier GPT-4. That's thanks to advances like chinchilla scaling laws, which help optimize models, and mixture of experts, MoE architectures.
Mixture of experts. That's at like different parts of the AI specializing.
Exactly. Different parts specialize in different tasks. And the paper expects another 1 to 3 4Ms of algorithmic efficiency by 2027.
So it's not just brute force compute. It's also about getting smarter with the algorithms.
Yeah.
Making the AI more efficient.
Precisely. Which leads us to the third driver, unhobbling gains. These are algorithmic improvements that basically unlock the latent capabilities already in the models. They were sort of held back or hobbled.
Unhobbling them. Okay, like what?
Well, key examples include reinforcement learning from human feedback, RLHF. This is what made models actually usable, helpful, safe, and commercially valuable. A small RLHF model could match a non-RLHF model 100 times larger in human preference tests.
Ah, so that's how they got them to follow instructions and sound helpful.
Right. Then there's chain of thought, COT. This unlocked step-by-step reasoning. It gave models a boost, like a 10x effective compute increase on complex math or reasoning problems. It's like asking the AI to show its work.
Makes sense, instead of just jumping to an answer.
Exactly. Then there's scaffolding. This lets models plan, propose solutions, critique their own work. Amazingly, a GPT 3.5 using scaffolding can sometimes outperform an unscaffolded GPT-4 on certain tasks.
So it's like teaching the AI better problem-solving strategies.
You got it. And finally, tools and context length. Models can now use web browsers, run code, handle huge inputs. Think Gemini 1.5 Pro learning a new language from scratch with over 1 million tokens of context.
That's truly mind-bending. It sounds like they're teaching AI to think more like us, with an internal monologue, access to tools. But what about the data wall? This idea that we're running out of high-quality internet data to train these massive models.
Yeah, the paper addresses that head-on. It acknowledges it's a valid concern, but it highlights that the big labs are making massive bets on things like synthetic data, self-play, and reinforcement learning approaches to get around it. Think about AlphaGo. It reached superhuman performance, mainly by playing against itself, generating its own data. The intuition is that models will learn to digest information more like humans do, through practice and internal reasoning, not just scraping the web.
Okay, so we've got these three powerful drivers: massive compute, smarter algorithms, and these unhobbling techniques all pushing forward exponentially. When you put these compounding trends together, what does Aschenbrenner project for the immediate future, like the next few years?
The conclusion he draws is stark. By the end of 2027, we should expect another capability jump roughly the size of that leap from GPT-2 to GPT-4.
Another GPT-2 to GPT-4 leap in just 3 years.
That's the projection. And this leap will likely take AI systems from that smart high schooler level to something like an automated AI researcher or engineer. A system capable of automating virtually all cognitive jobs.
Automating all cognitive jobs. That sounds, well, almost like science fiction. Can you give us a sense of how profound that impact would be, say, for a lawyer or a scientist listening right now?
It's profound. For a lawyer, imagine AI handling not just document review, but potentially drafting complex contracts better and faster than humans, identifying novel legal strategies, maybe even arguing certain cases. For a scientist, picture an AI designing new drug compounds, running complex simulations, hypothesizing new physics theories, and then designing experiments to test them, all at superhuman speed.
It fundamentally changes the nature of knowledge work itself.
Completely. Any job done remotely involving information processing, problem solving, it's on the table, according to this outlook.
Okay, so if that's where we're headed by 2027, where does it go next? The paper argues AI progress won't just stop at human-level AGI.
No, that's seen as just a waypoint. And this is where it gets potentially terrifying. The paper draws this analogy to the leap from the atomic bomb to the hydrogen bomb, from the bomb to the super. The bomb was like a more efficient bombing campaign. The super was a country annihilator. A different category altogether.
A qualitative shift in power.
Exactly. Once we get AGI, these systems will start automating AI research itself. And that kicks off what the paper calls an intelligence explosion.
An intelligence explosion. That's a dramatic phrase. What does that actually look like in practice? How fast are we talking?
Imagine not just one AGI, but millions of them. The paper throws out a number like 100 million human researcher equivalents. And they're working at, say, 10x or even 100x human speed. These automated researchers will have digested every research paper, developed superhuman intuitions, written millions of lines of incredibly complex code, collaborated at scales we can't even imagine.
Wow.
This could compress maybe a decade of human algorithmic progress that's 5 or more OMs into a single year.
A decade of progress in 1 year.
That's the idea. There might be bottlenecks like needing compute for experiments, but the paper argues these automated researchers could use existing compute at least 10 times more effectively anyway. It leads to this profound acceleration.
So what would this resulting superintelligence actually be like, beyond just being fast?
It'll be both quantitatively and qualitatively superhuman. Quantitatively, yeah, we could run a civilization of billions of these agents on future hardware, thinking orders of magnitude faster than us. But qualitatively, they'll exhibit novel creative behaviors totally beyond our comprehension. They could find subtle security exploits in code instantly, generate new types of code too complex for humans to even read, let alone understand, solve scientific problems that would take us decades.
The implications are just staggering.
Yeah.
The paper talks about a scientific and technological explosion, like a century of progress in years, an industrial and economic explosion, 30% plus annual growth, self-replicating robot factories, and perhaps most chillingly, a decisive and overwhelming military advantage.
Right. And even robotics, often seen as a physical bottleneck, just becomes another machine learning problem for these superintelligences to solve.
So they won't just use robots, they'll rapidly improve robotics itself.
Exactly. Designing and optimizing them at a superhuman level, essentially eliminating that bottleneck.
Okay. With such immense power, growing so rapidly, this obviously brings immense challenges. The paper outlines several critical hurdles if this future is really just around the corner.
It does. First, there's the challenge of actually building the infrastructure, racing to the trillion-dollar cluster. The scale of industrial mobilization needed is just staggering. By 2030, the paper suggests the largest training clusters could cost over $1 trillion.
$1 trillion?
Yeah, and require 100 gigawatts of power. That's, like we said, over 20% of current U.S. electricity production. It means building hundreds of new power plants, securing immense quantities of advanced chips.
Can we even do that? Physically?
Yeah.
Economically?
Well, the paper notes the U.S. has abundant natural gas.
Yeah.
But self-imposed barriers like, environmental commitments, slow permitting processes, these are seen as significant obstacles. And China is highlighted as a formidable competitor with its emerging 7-nanometer chip capabilities and a very different regulatory environment. They could potentially outbuild the U.S. in compute.
Right, the geopolitical race element. So, assuming we can build these things, what about securing them? These incredibly powerful systems.
This is where the paper gets really alarming. Its assessment of current AI lab security, it calls it Swiss cheese.
Swiss cheese? That doesn't sound good.
No. It basically states that American labs are handing the key secrets for AGI to the CCP on a silver platter. It cites things like the FBI director warning about Chinese hacking, mentions that example of Google AI code being easily exfiltrated via Apple Notes.
Wait, via Apple Notes? How does that even work?
Apparently, an employee copied code into Apple Notes, converted it to a PDF, and uploaded it right off the Google network. Simple as that.
That's shockingly low-tech for stealing secrets to world-changing AI.
It highlights the problem. The critical assets are the model weights the AI's brain, those files of numbers, and the algorithmic secrets, which can give a 10x or even 100x compute advantage, a massive head start.
So, less Fort Knox, more. A garden shed with a flimsy lock. What's the proposed fix for this Swiss cheese situation?
The paper calls for supersecurity, a level of protection that, it argues, is currently only achievable with government involvement. Think air-gapped data centers, military-grade physical security, SCIFs, those sensitive compartmented information facilities for personnel, extreme vetting, constant monitoring, multi-key sign-offs for critical actions, intense penetration testing by agencies like the NSA.
Basically treating AI secrets like the highest-level nuclear secrets.
Precisely. It draws a parallel to Leo Szilard's urgent pleas back in the day for atomic secrecy, which proved decisive in the U.S. beating Germany to the bomb. History repeating, perhaps.
This leads to maybe the most fundamental question. Even if we secure it, can we even control systems that are potentially vastly smarter than us?
That's the core of the superalignment challenge. And the paper is pretty blunt about it. Current alignment techniques, like RLHF, rely on human supervisors understanding what the AI is doing. But these methods will predictably break down when faced with a superhuman AI that can, say, generate code in new languages we don't understand, or make complex strategic decisions beyond our grasp.
So we won't even be able to tell if it's doing what we want it to do.
Or worse, a misaligned superintelligence could learn to deceive us. It could lie, commit fraud, hack systems, manipulate things, seek power to achieve whatever objective it has, even if that objective seems benign initially. The consequences could be catastrophic.
That's Yeah. What's the default plan then, according to the paper, to try and tackle this potentially existential challenge?
It's multifaceted. It involves developing scalable oversight, basically, getting AI to help us supervise other AI, improving generalization so AI behaves safely even in novel situations, and developing top-down interpretability tools, things like AI lie detectors or ways to ensure we can follow the AI's chain of thought.
Using AI to help manage AI seems recursive.
It is. The hope is to align somewhat superhuman models well enough that we can then use them to automate alignment research for the really advanced systems that follow. But that intelligence explosion makes the timeline incredibly tense. The transition from human level to vastly superhuman might happen in less than a year.
Less than a year.
Yes, leaving very little time for critical safety decisions, especially amidst high-stakes international competition. So super defense measures are also crucial: extreme security, constant monitoring AI, maybe even deliberately limiting certain capabilities, multiple layers of protection.
And it sounds as a race against time on multiple fronts.
Yeah.
Security, alignment, capability, all accelerating.
And that brings us back to the geopolitical stakes, which the paper frames as absolutely paramount.
Right. The free world must prevail. That's the framing.
Yes. Superintelligence is seen as conferring a decisive economic and military advantage. The paper compares it to the kind of technological disparity seen in the Gulf War, where a tech lead of a few decades allowed the U.S. coalition to utterly decimate a numerically superior Iraqi force. It warns against underestimating China. If China wakes up to the AGI race, it argues, they have a clear path to compete by simply outbuilding the U.S. on compute and potentially stealing algorithms, given the security issues.
And the risk isn't just losing a military edge. It's about the nature of the power itself.
Exactly. The authoritarian peril is described as profound. Imagine a dictator wielding superintelligence. They could potentially lock in permanent totalitarian rule, crush all dissent, monitor and control society completely without any risk of coups or rebellion. It's a terrifying prospect for liberty.
And the paper is pessimistic about international cooperation. Yeah. Treaties.
It deems international safety treaties fanciful, unfortunately. The incentives for a nation to break out and achieve superintelligence first are just seen as too immense. The primary hope, from this paper's perspective, is an alliance of democracies, led by the U.S., securing a healthy lead, maybe 2 years, to navigate the transition safely and then enforce global safety norms from a position of strength.
A 2-year lead. That sounds like a very narrow window for ensuring the future of, well, everything. Now, the paper paints this stark picture of the authoritarian peril, and it dismisses treaties. But just to explore alternatives briefly, are there any proposals out there, even if Aschenbrenner finds them unlikely, that try to bridge these divides for safety?
Well, outside this specific paper, yes, people in the broader AI safety and ethics community do discuss things. Ideas like international research collaborations on safety, maybe independent auditing bodies for powerful AI systems, even exploring game theory concepts like mutually assured destruction scenarios adapted for AI. But Aschenbrenner's core argument is that the sheer speed and the winner-takes-all nature of the race itself will likely make such cooperative efforts unworkable in practice. The pressure to not fall behind will be too great.
Right, which brings us back to the scale of the challenge. It really feels like these stakes are just too high for private companies, for startups, to handle alone. This isn't just another app or gadget.
Absolutely. And the paper argues exactly that. No startup can handle superintelligence. It draws those parallels again. The Manhattan Project, the government's response to COVID-19, asserting that the national security apparatus will inevitably get involved. It's not a matter of if, but when. It describes 2023 as the AI wake-up moment and predicts that by 2025, 2027, AI capabilities will genuinely shock the world. Think $100 billion plus annual revenues for the big tech AI players. AI is routinely outperforming PhD researchers in their own fields. That kind of shock.
And when that shock happens, what follows? What does the project look like? Is it outright nationalization of AI labs?
Not necessarily outright nationalization, no. The paper envisions more of a suave orchestration. Leading AI labs might voluntarily merge their efforts into a single national project. Congress would appropriate potentially trillions for the chips and the power infrastructure, and the whole thing would operate under the helm of the U.S. government.
A public-private partnership, but with the government firmly in the driver's seat.
Essentially, yes. The core argument is that superintelligence is fundamentally like nuclear weapons, not like the internet. It demands a sane, accountable chain of command, the robust institutions of a democratic government, things that, frankly, private CEOs and venture-backed startups just don't have and aren't designed for.
So Military applications would stay under tight government control, but maybe civilian uses could eventually flourish privately.
That's the idea. Similar to how we have nuclear energy regulated by the government or commercial aviation overseen by the FAA. Civilian benefits, but under strict governmental oversight and control, especially initially.
That's a really significant shift in how we normally think about tech innovation, certainly in the West. Usually it's private sector leads, government follows or regulates later. This flips that script. So as we wrap up this deep dive into Aschenbrenner's situational awareness, what's the single most, uncomfortable truth this paper forces us to confront?
For me, it's encapsulated in his concept of AGI realism. It boils down to three core tenets he lays out. One, superintelligence is fundamentally a matter of national security. It's not just a tech boom, it's potentially the most powerful weapon or tool ever created. We have to treat it that way.
Okay. National security first.
Two, America must lead. The paper argues this is crucial for the survival of liberty globally, and paradoxically maybe, the only realistic path to achieving safe AGI is if a leading democracy gets there first with a significant lead. This implies aggressively scaling U.S. power, securing the labs, ensuring U.S. control of the core infrastructure.
A call for national focus and investment on an unprecedented scale.
Yeah.
And the third tenet.
Three, we need to not screw it up. Recognizing the immense peril means managing the risks incredibly seriously, no improvising, being willing to make very hard trade-offs between speed, safety, and openness.
Don't screw it up. Simple, but profound given the stakes.
And the author, Aschenbrenner, describes his own personal shift. From understanding AGI abstractly to having this visceral realization of its seeming inevitability. He even claims he can almost see the cluster AGI will be trained on, the rough combination of algorithms we'll use. It sounds like he feels it's becoming concrete.
That's quite a claim, almost prophetic sounding.
It is, but maybe his most important and honestly scariest realization he shares is this. There is no crack team coming to handle this. There is no secret group of experts in a bunker somewhere managing this transition. The responsibility, he says, falls on you and your buddies, the very small number of people who actually have this situational awareness.
Wow. So the cavalry isn't coming because they are the cavalry, whether they like it or not.
That's the unsettling message. It's a tiny group who understands what's potentially coming, and the burden, according to this paper, is squarely on their shoulders.
This deep dive really paints a picture of a future that isn't just near. It feels incredibly urgent, demanding our collective attention right now. It leaves us with these profound questions, doesn't it? Will the free world actually prevail against these unprecedented technological and geopolitical challenges? Will we manage to tame superintelligence, align it to human values, or will it somehow end up taming us? Can humanity navigate this transition, skirt self-destruction once more, faced with power unlike anything before? Aschenbrenner's paper, whether you agree with all its conclusions or not, serves as a stark reminder. The future isn't just something that passively happens to us, it's something we are actively building, or perhaps failing to build, with the decisions we make today. It really feels like a call to action for anyone listening. The burden of history feels heavy right now, and the future, as Aschenbrenner puts it, is about to get very, very real.